Hi, my name is Charlie Wootton. I'm with the Piedmont Soil and Water Conservation District, and I'm a conservation specialist. Today I want to talk to you a little bit about something that's very important to all of us, and that's soil. Our soils are really important because most of what we eat and use and wear as clothing comes from the soil. Our plants, of course, come from the soil. Trees that we build our homes out of come from the soil. Our livestock eats plants that are grown on the soil. Some animals are plant eaters. Some animals eat other meat, but all of that ultimately goes back to something eating something grown in the soil. So our soil is vital to our life. And what I'd like to talk to you about today are some layers of soil and the one that we really want to focus on. I'm holding in my hand what's called a soil profile. And we get these by drilling a round hole in the ground, pulling out a plug of soil, and then we cut it in half and mount it in a piece of PVC like you see here with glue so that you can study it. But this is an actual soil profile taken from ground in Virginia. Soils have different layers to them, different levels, different layers. We call them horizons. But there are three general layers that we want to talk about today, and that's topsoil, subsoil, and bedrock. In this particular case, you can see very clearly the three different layers. So I'm going to ask you, where do you think the topsoil is? And the name of the soil is a clue to where it is. That is your topsoil, and you'll see it's about 6 inches in depth. That's about the average topsoil depth or thickness of topsoil in our parts of Virginia. It varies from 4 to maybe 12 inches, but 6 is a good average number. So we have 6 inches of topsoil. The next layer is what we call subsoil. So it's between the topsoil and the bedrock, which is where the soil is the parent material, we call it. So where on this profile would you think that the subsoil is? So if you're looking down, you'll see that things really start to change somewhere right in here. And as you get further down, we've got a lot of rock. So our subsoil is somewhere in this area here up to here where the topsoil is. And of course, below that is what we call bedrock, which is the parent material that the soil ultimately comes from. Now, it may take hundreds or even thousands of years for the bedrock to be broken down by rain and weather and the movement of the earth to become topsoil. Topsoil also has what we call organic matter in it, and that would be your dead animals, the dead leaves off of trees, your dead grass. As it dies and decays, it's called organic matter, and that's what gives your topsoil the dark color. So we have discussed the importance of topsoil, how long it takes to make topsoil, and why we depend so much on our topsoil. What we would like to discuss now is ways we lose our topsoil, and the way we lose topsoil is called mainly erosion. There are two types of erosion, wind erosion and water erosion. In Virginia, we're not too concerned about wind erosion. It is a huge problem in the Midwest where the land is very flat, there are few trees, and they do a lot of tillage. In Virginia, we're mainly concerned with soil loss due to water erosion. There are three elements of losing soil due to water erosion: detachment, transportation, and deposition. Detachment is when the raindrop hits the soil, it detaches particles of soil. They are then washed with the rainwater, and that's called transportation. And they will go downhill or into a pond or a lake or a stream, and then when it settles out, it's called deposition. So you have detached the soil, transported it from one location, and are deposited in another location. When a raindrop hits bare soil, it's similar to a hammer striking the ground. Fine particles of soil are detached when that raindrop hits. It's a tremendous force that the raindrop exerts upon the soil particles because the particles are so small. Anything we can do to keep that raindrop from impacting the soil directly will help decrease our erosion. For our demonstration, we have 3 boxes set up. One of them is just bare soil, like you would find in a field that has been plowed and cultivated. The second box is the same soil, but we have residue left on it, such as you would find if you harvested corn or wheat and left a straw on the land. And the third box is a box that has a living cover on it. In other words, the crop is growing. In this case, we're using grass. The added benefit of the one with the living cover is we have roots that go down into the soil that allow the water to penetrate and also hold the soil in place. We're going to simulate rainfall on each of these 3 boxes and determine which box results in the less amount of erosion. As we do this, you will notice that some boxes have more runoff or transportation than the other boxes do. I'll let you think about it for a minute to which box you think will have the most runoff. We're now going to rain on the bare soil box. We're now going to rain on the box with the dead cover. Now we're going to rain on the box with the living cover. I do want you to know that we use the same amount of water on all 3 boxes. So let's evaluate what our demonstration shows. From box number 1, the unprotected soil, you can see that we filled the jar with water. If you look at the bottom of the jar, we have about an inch of soil that has already filtered out of the water and settled to the bottom. So the question is, did that soil absorb any water? The answer would obviously be very little, because we had enough runoff to fill the jar, and it took with it our valuable topsoil. It also took with it whatever fertilizer or chemicals may have been on that soil, or if the farmer had just seeded that soil, it probably washed his seed off too. For box number 2, which had the same soil in it, but we had some dead matter left on the top, you can see we had less than half the amount of water ran off. And you can see that there's very little of the soil in that water. At the bottom of the jar, that's just a real thin layer. That means that more rainfall stayed on this farmer's field, even though he didn't have a living crop on it. He had left his straw, and it protected his soil. Box number 3, as you remember, had the living cover. If you look at the jar, no water came off of that field. There's no soil in the bottom of the jar. That means that this farmer, every drop of rain that hit his field was absorbed by the plants in that field, and all the water stayed in his field. If he had fertilizer or chemicals on that field, they stayed there too. The thing that helps that is not only did we have a cover that broke the impact of the rain drops, we also had that on box number 2. But this is living cover, and it has roots, something the other box did not have. The roots take all of that water that has been dispersed by the cover and filters it down into the soil. Each root makes a little channel in the soil, and that allows oxygen and water to seep down into the soil. Everything that the farmer got on this field rain-wise is still on his field, so he's got water to grow his next crop. So to summarize, it rained the same amount on all 3 of these boxes. We used the same amount of water, and the bare soil did not absorb hardly any water, and we lost a lot of topsoil. By just covering the soil with something, we lost less than half the amount of water and very little of the soil. And the best of all worlds is to have a living cover. You lost no water and no soil. We use this demonstration for farmers to show them the value of planting cover crops in the wintertime after they have harvested their fields. This allows you to have a living cover on that field during the winter when you have a lot of rain and snowfall. And that is the purpose of this demonstration, to show you not only do you reduce the erosion, but you ensure that you're keeping the water on your field when you get rain. Also, this experiment shows something else. What do we call it when something gets in our water, our stream or our river or our lakes, that makes the water quality go down or makes the water undrinkable? Does anybody know what that word is? It starts with a P. The word is pollution. And from box number 1, not only does the soil wash down and contaminate our water, but whatever chemical or fertilizer that was on that field washes down too, and that pollutes our streams. So not only do we save our topsoil by protecting it, we also protect our water by protecting the topsoil. This field obviously lost half the water, so you didn't have the pollution going downstream that you would from the first box, but you still have some runoff, so you still have some pollution. Again, the best situation is a living cover where you didn't have any runoff on the field, so whatever chemical or fertilizer that was on that field remains on that field, and it doesn't pollute our drinking water. What I would ask you to do is, as you ride back and forth to school or around your neighborhood, see how many fields you see that have a living cover on them, or how many fields do you see that have been completely plowed and disked and bare soil. I don't think in our part of Virginia you're going to see much bare soil anymore, but take a look and see as you ride around, pay attention. Thank you.